Good morning, everyone. Uh, Today I'm here to talk to you about how to turn any positive integer or real number, as it may be called, except for 0, which may be considered any number except for 0, into a sum of powers of 2 with theoretically almost any number, even super large ones like a duodecillion or anything like that. But you might not always need those. So here's a list of powers of 2, and I seem to have taken out 2 to the power 8 for some reason. Maybe, actually no, it might have been an accident. So there you go. And you don't have to memorize this, but if you want to, it will be very useful. So what you can do is, here's an example. So what we can do is find the closest power of 2 that is an integer power. So that's integer power, so that would be 128 in this case. Alright, 128 plus, so 128 is equal to 2 to the power 7 plus, and we make it under series like that. And now 224 minus, so it's basically turning it into a series that consists of powers of 2, minus 128 equals 96, and 96 can be compiled into 64 plus 32, which is very nicely convenient. Sometimes you don't have to be orthodox with the methods. And these separately equal 2 to the power 6 plus 2 to the power 5. And there's not enough space here, so I'll just compress this a bit. 2 to the power 7. It's a bit small, so I'll make it larger. Plus 2 to the power 4 plus 2 to the power, no, plus 2 to the power 6 plus 2 to the power 5. And I may or may not build up on use of this later, but I might seem useful to just compile it into powers of 2. In this case, it's very convenient if you want to, because you can factorize it. So you could do something like this. If there was a question like in separate times, like using a sum with powers of x that are continuously high, you could use this because you can factorize it. So in this case, it shows how you can compress the normal numbers except for 0, all the other normal numbers, into a series like this. And let's try a question, shall we? So what we can do is x cubed x equals, let me think of something. There you go. There you go, 39. Now the main subject of this video was actually should have been how to present any number like this, which might look very nice. You can also do this for odd numbers. You just have to add 1 at the end, which is equal to 2 to the power 0, and it's really nice. And I guess it looks nice turning it into a finite series. But another something branching off from this, because I may or may not find it used for this later. So moving away from this, what we can then go to would be how showing proof of reoccurrence. Solving by reoccurrence. Now, even if there's more than one solution, which in this case there definitely is, you're not going to get all of them. In this case, you're only going to get one. However, what you can do, and since you don't need the cubic equation, or what you can do without forms of factorizing, is you can solve one solution of x by putting this into a series. So 39 equals, you can make this into a series of 3 to the power of 3. So 39 equals 3 squared, you can see from the 9, plus 30, we just, and this next closest one is 27, so and that's 3 cubed. Alright, 3 cubed, and the weight plus 3. So then that means that x squared, so x cubed plus x squared plus x equals, say x cubed plus x squared plus x equals 3 cubed plus 3 squared plus 3, right? Now x equals x to the power 1, and 3 equals 3 to the power 1. And as you can see, they seem to be showing 3 cubed, x cubed, they do correspond, right? So we can already tell that x, we should be able to tell that one version of x is 3. Okay? And there are more versions. And if we look at the formula, if you turn this into equation, so equals 39, let's take minus 39 and do that. As you can see, the cubic equation goes down very much and doesn't look very vibrant. You can also do this, but it's not really important. And as you can see, the only real solution would be this. Now, thankfully, since I wouldn't exactly expect, at least from year 10s or 11s or maybe 12s, to find all the solutions, especially the imaginary, but you could try, and yet it would require a tedious equation called the cubic equation, which is just long and difficult to remember for most people, except maybe those with photographic memory. So see you guys later.